Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab. That channel specially created for you and I to demystify mathematics and come together to tackle the age-long phobia associated with this all-important subject, one topic at a time. So this class, which promises to be interesting, exciting, and fun, most importantly, is a continuation of our topic, Quadratic Equation, the series. In our last lesson, we looked at how to generate or form or construct a quadratic equation with a given roots. And the highlight of the class is that if you are given any two roots whatsoever they are, all you need to do is find their sum and their product and insert or substitute in an already customized equation, which is x squared minus sum of the roots times x plus product of the roots, of course, equals to 0. Meaning you have, by default, x squared minus the sum of the roots times x plus then product of the roots equals 0. That essentially is the customized equation you're going to slot in the values. And we try some examples. All we need to do is to just find the sum and find the product and insert. However, as an observing student or candidate, there are times that the question might be a bit deceptive if you're not careful. And that's the essence of today's class, whereby you are going to be given the sum and the root already. So if you are not very observant, you might mistake this part with the previous one. I mean, look at this question. If you look at this question, if you are not very careful, you might be quick to attempt this question using the previous class's idea. But there's a slight difference which you must not fail to take note of. These are not roots given. Rather, look at the question. Form equations in X whose sum and product of roots are respectively. Meaning these are already summed and multiplied. So you need not do sum and product again. As a matter of fact, this is a lot simpler than the previous one. So they've done the sum for you and the product for you, respectively. Just slot in. That's the meaning. So for number one, of course, this still applies. We're going to have x squared minus sum times x plus product equals 0. Instead of saying sum 3 plus minus 5, no. The question says sum and product already given. So, in other words, for the question 1, that 3 is just the sum. Direct substitution plus product is minus 5 equals 0. Hence, you have there x squared minus 3x minus 5 is 0. Pure and simple. So, there's every tendency for candidates in most cases to always lump them together. No. So, take note. If you are given roots, whose roots are, then you can use the previous approach. However, if you are given whose sum and products are, that means you don't have to take it too far. The sum and products have been done. All you need to do is to slot in or substitute. And that's the answer. For number 2, here, still the same idea. We have x squared minus sum, of course, times x plus product equals 0. So we have x squared minus, the sum here is minus 6x plus the product is 0 equals 0. So we have here x squared plus 6x, everything equals, because this 0 is inconsequential. And that's the solution as well. And lastly, Lastly, we have x squared minus still the same formula, sum plus product equals 0. So we have x squared minus the sum here being 2/5 x, and the product is 1/2 equals 0. And as usual, you have to clear the fractions here. How do you do that? Use the LCM of the denominators, and they are 5 and 2. LCM of 5 and 2 is 10. Multiply 2 by 10, I have 10x squared minus 10 times 2/5, that will be 4x, plus 10 times half, that is 5, equals 0. And that does it. That does it. It's as simple as that. So I believe you found it quite interesting and simple. So this is more or less like a follow-up to that previous video, the last video. And the essence there is to sound a note of warning, not to confuse this particular part of question with the previous one. Here we are given this sum and products directly. All you need to do is to do a direct substitution. You don't need to do a separate sum and product again. If they were ruled, then that approach would have been relevant, but not this. So I think you find this video very, very insightful and explanatory as an expert. If you do, please don't forget to subscribe, share, and try as much as possible to tune in your button so that you'll be the first to know when our next video is dropped. And we are going to be going deeper into this part of quadratic equation series. Stay tuned and stay blessed.